Hello. In this presentation, we are discussing about the various concepts of thermodynamics. Thermodynamics is an applied science which is used in several branches of engineering, including mechanical and chemical engineering, and in the field of heat transfer, refrigeration, heat exchangers, energy conversions, etc. It is the study of energy and its relationship to the properties of matter and all activities in nature involving some interaction between energy and matter. So thermodynamics is basically is the study of energy, its use and transformation through a system. Typically, engineering thermodynamics is concerned with the changing energy from one form to another. As an example, automotive engines convert chemical energy from the fuel into heat and then into mechanical work that eventually turns the wheels. Thermodynamic systems. A thermodynamic system is defined as a quantity of matter or region in space under consideration for analysis. And example of systems are like piston cylinder assembly, turbine, etc. The system is identified by a boundary around the system. The boundary may be real or imaginary, and everything outside the system boundary is called surroundings. A system and its surroundings together are called the universe. Now, the types of system. The system may be divided as open, closed, and isolated system. Open system in which only mass is cross the system boundary in either direction, and in closed system no mass is permitted to cross the system boundary, and we do permit heat and work to enter or leave but no mass. And in isolated system there is no interaction between the system and the surrounding, means nor mass, neither heat and nor mass don't uh, cross the system boundary, means there is no mass and energy transfer across the system boundary. Another term used in thermodynamics is temperature, which is the qualitative indication of relative hotness, can be exactly defined by using thermodynamic property known as temperature. In SI unit, the thermodynamic temperature is represented by Kelvin, and in more practical purpose, the Celsius scale is used for measuring temperature, as it is denoted by degree Celsius. There are two terms, STP and NTP. STP is standard temperature and pressure, and NTP is normal temperature and pressure. The another term used in thermodynamics is energy. Its unit is kilowatt hour, which is derived from the unit of power kilowatt. It is possible to convert one form of energy into another form of energy, and heat engine is a device which convert heat energy into mechanical energy. The types of energy are potential energy, kinetic and internal energy. Potential energy, which a body possesses by virtue of its elevation or position. For example, water is stored at higher level in a dam, and it is represented by Pe equals to mgh, where m is mass, g is gravitational constant, and h is height. Now another is kinetic energy, which a body possesses by virtue of its motion, like jet of water coming out from nozzle. and K equals to half mv square. Next is internal energy. Internal energy is one type of energy which is neither heat nor work. Hence, it is a stored form of energy and it is denoted by U. Mathematically, we can write Q equal to W plus U, where Q is amount of heat, W is work, and U is internal energy. The internal energy per unit mass is called specific internal energy, and for non-flow processes, heat transferred through system boundary is equal to the work transferred through the system boundary plus change in internal energy. Next term is heat. Heat may be defined as the energy interaction at the system boundary which occurs due to the temperature difference only. When heat is removed from a body or supplied to it, there are some changes found to happen, such as change of temperature, change of volume, change of state, change of physical property, etc. Another important term is specific heat. Specific heat capacity of a substance may be defined as the quantity of heat required to raise the temperature of unit mass of the substance by 1 degree, and its unit is kilojoule per kg Kelvin or kilojoule per kg degree centigrade. Mathematically, the heat transfer rate Q is written as Q equal to mCp or Cv dt or delta T. Here this C is specific heat, m is mass of substance, and delta T is the temperature difference in Kelvin. The product of mass and specific heat is called heat capacity of the substance. The another two important terms is work and power. Work is said to be done when a force moves through a distance. If a part of boundary of a system undergoes a displacement under the action of pressure, the work done is the product of force and the distance it moves in the direction of force, and the unit of work is Newton into meter or joule. Next is power. Power is defined as the rate of doing work, or the power is work done per unit time. So mathematically, work done per unit time is joule per second, and in SI unit, joule per second is called simply watt, or kilojoule per second is called kilowatt. Now next is laws of thermodynamics. There are some law related to thermodynamics, like Zeroth Law deals with the thermal equilibrium and provides a means for measuring temperatures, whereas First Law deals with the conversion of energy and introduces the concept of internal energy. The second law provides the guideline on the conversion of internal energy of matter into work, and it also introduced the concept of entropy. And the third law of thermodynamics defines the absolute zero of entropy. The entropy of pure crystalline substance at absolute zero temperature is 0. Now, first law, if two systems, say A and B, are in thermal equilibrium with a third system C separately, then they are in thermal equilibrium with each other. Like you can see in this figure, if TA and TB having the same temperature with C individually, then TA and TB must be having equal temperature. Now, first law of thermodynamics, It provides for studying the relationship between the various forms of energy and energy interactions. This law states that energy can neither be created nor be destroyed, it can be converted from one form to another form. And it may be expressed as change in total energy equal to net energy transferred as heat and work. So del E equals to Q minus W we can write, and del E equal to Q minus W. So here we can write del U plus del KE plus del PE, like all types of internal energy. In closed system, mass is fixed and there is no elevation difference. So delta K equal to 0 and delta P potential energy equal to 0. So delta U, that is internal energy, equals to Q minus W. The last is second law. Second law is defined by using two statements. First is Clausius statement. According to this, it is impossible to construct a device which, operating in a cycle, will produce no effect other than the transfer of heat from a low temperature to high temperature body. Means heat always flow from a body at higher temperature to a body at a lower temperature. The reverse process never occurs spontaneously. Similarly, the second statement, Kelvin Planck, it states that it is impossible to construct a device that operates in a cycle and produces work while exchanging heat only with a single reservoir. Means it it restricts that the thermal efficiency of heat engine to less than 1, and some portion of energy absorbed as heat from a source must always be rejected to a low temperature sink. So second law is based on these two statements, and that's all. This is all about concept of thermodynamics.